Okay, this is for HL math, HL2 math. Okay, so if you need any of the questions explained and not just looking at the solutions, this is the stream of consciousness version that we usually do in class. The only thing is you guys won't be able to answer me, just answer myself. Okay, so this is paper 1, time zone 2 of 2017. So pause while you go get that paper. And you definitely want to try the questions first before you correct it. So this is just our class time. Okay, so let's see. We'll start with the short answers, and when the video gets to about 25 or 30 minutes, then I'll stop wherever we are, and then I'll start a new video. Okay, so question number 1. So instead of just going through, I'm going to go through all of the questions, where usually I only go through the ones that you guys want, but now we can go through them all because we have more time. Okay, so 2x squared plus 1 over 2x cubed to the 10th. So now you already tried this one, so you probably remembered what to do. So what does this remind you of? Are you allowed to distribute the 10 to each? Hopefully you realize that that's not allowed. Okay, so what is allowed? What do we do? What kind of problem is this? Okay, so I would say Pascal, but I'm a little worried because the n is 10. Very worried. Don't feel like doing Pascal. So instead I'm going to use binomial. Now, binomial and Pascal are basically the same. The only difference is that instead of drawing the actual triangle, where you would draw that in Pascal, the binomial tells you that the coefficients are those c's. So this would be 3c0, 3c1, 3c2, and 3c3. My arrows don't quite line up with my c's. And then, so here's these values. And then it would be your choice whether you want to go all the way out to the 10th or not. So I'm going to go for not going out to the 10th. So what I'm going to do is I'm going to start it here. So this is NC0, NC1, NC2. And we'll see, oh, it's not N. N is 10. So 10. And you could also start with 10C10. So that's up to you. And then I know it has to be 2x squared to the 10th. And then I don't have one here. If you want to, you could write 1 over 2x cubed. We kind of do like a little dashed parentheses. Let me pretend this is invisible. So this is invisible. And that would be, think of the way you did probability. So when you do probability and you do binomial, don't you put this to the 0 power? And then these are timeses in between. If you're tutoring younger students, definitely put the timeses in between, because otherwise they don't get it. Okay, and then this would be 2x squared to the 9th. And then 1 over 2x cubed to the 1st. Now, this number here that's at the bottom, you could choose either exponent. So the 1, or you can choose the 9. So that's up to you. Okay, now that I kind of understand the question, I want to see what they're actually asking me for. So they don't want all 10. They said find the term independent of x. If I didn't know what that was, I would just find all the terms. So independent of x. What the heck does that mean? So independent of x means there's no x. So I need to find the one with no x. But if you just started working it out, I think that you would get some partial credit. So let's see. This one is going to have an x to the 18th. Right? Look at this exponent. This exponent's an 18. This exponent's a 3. So that's a 3 in the denominator and an 18 in the numerator, so that one's not going to work. That one's a 20, and then this one's not even really here, right? Because it's to the 0 power. So I got to figure out, and maybe there's more than one. So I don't know if there's only one or there's more than one. So 2x squared to the 8th, 1 over 2x cubed to the 2nd. So that's what, x to the 6th, 16. Okay, we're getting closer. So this would be, let me just look at the x's. So x squared to the 6th and x cubed in the denominator to the, not that wouldn't really be to the 6th, hold on. So that'd be to the 7th, and this one would be to the 3rd. How are we doing? So we're at 14 and 9. My problem is I don't know if there's more than one. So that's the only reason where I'm a little wary. Okay, so this is to the 6th. This one, x to the 3rd, would be to the 4th. Ooh, that one looks good. Doesn't that one look good? So look at these exponents. I'll highlight it in blue. This one's a 12. This one's a 12. Hey, I think that's pretty good. I think that's going to work because that's going to cancel. Okay, let's just do the next one to see. So that's x squared to the 5th. And I guess we can have the 1 over, it is a 2x cubed to the 3rd because they add up to be 8. This one is, let's see, I was about to erase, 9. This one's 10. So I would say that is going to have an x, right? That's going to have an x to the 1, x to the 10th in the numerator, and then x to the 9th in the denominator is going to give me an x. Okay, so I like the blue one. So my blue one is my plan. Now, when they show you the answer in the mark scheme, they just have the answer. So they already know which term it is. So that doesn't do the thinking process. So the thinking process is more like this. What work do I actually have to do to figure it out? Okay, so I'm going to go back and fill in the missing stuff. So this is a 2. This is a 1. There's a 2 here. And then what do I put in the front? Now you get to pick. So this little green spot right here, you get to pick. So you can pick the 6 or you can pick the 4. Because of the symmetry of the binomial, the NCR formula, it doesn't matter which one you use. So if we're going to look at the way I was doing it before, it matched the back exponent, but it really doesn't make a difference at all. So let me work this one out. Now 10C4, I am on the calculator section. So make sure that you have your calculator in the way, like overlapping your problems here. So here's your calculator. Okay, because otherwise you're going to forget you have it. Okay, so put your calculator in the way while you're doing the paper 2 questions. Okay, so let me undo that because we don't really need a calculator in the way of our problem here. Okay, so and then this wasn't helpful, right? I mean, this was my work, but I don't really need, those weren't quite right, so I'm going to cross this out. Okay, so this is 10C4, which I'm going to do on my calculator. I can go to another screen and go on my calculator. I guess it's going to get too big, so let's use 10CR. Oh, let me show you the way the mark scheme is going to do it. The mark scheme's not going to show that because IB likes to put their combinations in this format. Kind of looks like a vector, so it's a little strange for us. Okay, and then this is 1 over 2 to the 4th, x to the 12th. The x to the 12ths cancel like we expected. Oh, the 2 to the 6th, look, I don't need a calculator. 2 to the 2nd, so this is 4 times 10C4. Now I can go to my other screen, so please use a calculator on this, but I don't want to go to my other screen. So I'm going to use 10 factorial, pretend, what if it was a non-calculator? So that would be 6 factorial, 4 factorial, but this is definitely not work that you would show, so I'm going to put it in a bubble because you're using your calculator. Use calculator. Okay. But for me, I don't have a calculator. Well, I do on my computer, but it's kind of a hassle. Let's get over there. Expand it, 6 factorial, 4 times 3 times 2 times 1, chop, chop. Let's see, chop, chop, chop. Chop, chop, 3, 210. Yep, so 210 times 4, 840. Hopefully, that's the right answer. But you know, definitely are not perfect on the calculations. So really type it into the calculator. It's totally fine to just get the answer from the calculator over here. All of this is my non-calculator work. Okay, so if it was on the non-calculator section, we could still do it. So that's kind of exciting. Anyway, with the calculator section, make sure your calculator is somewhere in the way. Otherwise, you are not going to notice you have a calculator and you're going to forget. Okay, so, oh, that was a 9-minute problem, and I think it was only 5 marks. Okay, so me and my rambling. Okay, the function f is defined by, so f of x equals 2x to the 3rd plus 5. And there's a domain restriction. Okay. I wouldn't need a domain restriction. They just restricted it for some reason. So it says, what's the range? Now you need to be careful with the range. I would say, oh, the range, I'm on the graphing calculator section. See, I got to put my calculator right in the way. Put your calculator right here in the way so that you don't forget. What if this was on the non-calculator section? I do want you to know that it's not automatic that if you substitute this in and you substitute this in, that that's going to be your new range. This problem accidentally works that way, but let me just show you a sample. say you had this problem, -2 to 2, and say you were just looking at a simple parabola. Okay, so say you were looking at a simple parabola, just a regular y equals x squared problem. Now imagine the domain was 2 to -2, and the equation was, let's say, g of x equals x squared. If you just plugged in the numbers here and said the range is this number substituted, look at that range. Start at 4, end at 4. That's not the real range. So what's the real range? The real range is 0 is less than or equal to y less than or equal to 4, which you would not have been able to tell from this. So anytime you want to look for the range, always graph it. Now, I was thinking I was going to need to hand graph it, but you have your calculator, so you can use a hand calculator. Okay, so I'm not going to use a hand calculator because I have to go to my other screen. But basically, I do need to label my calculator. So I kind of know what it looks like, you know, because I'm a math teacher. So it kind of looks like this, right? At 2, I get a value. At -2, I get a value. Oh, that's interesting. I wonder where -2 actually is. So -2, so f of -2 is 2 times -2 cubed plus 5. That's what, -16 plus 5, -11. And then f of 2 is 2 times 2 cubed plus 5, which is 16 plus 5, which is 21. Now, I really don't like how this problem has the range between 21 and -11. It's very disturbing for me as a math teacher because I know this other situation over here that I'm highlighting in yellow, which is that ranges do not just come from the endpoints. And in fact, this other problem over here that I have 0 to 4, I mean, what if I was going -1? So what if I was starting at -1 and then going to 2, right? Say I was just going to here. I mean, my domain would still be 0 to 4. I mean, my range would still be 0 to 4, even though the -1 endpoint doesn't give me the 4. So very disturbing. Make sure you draw a picture. You might need to use calculus, minimum, maximum, etc. A says write down the range. So really, the range is just going to be to the 2 values. I would say to graph it, I'd show a picture because that's the only thing that really convinces me. If you don't have a picture, I would say you really don't know for sure because you don't know if there's a minimum or a maximum or something like that. Anyway, write down means you don't really have to show any work. So all this rambling. And you would have gotten the answer if you just wrote down this. So if you drew the picture and you looked at it, that would be fine. I do suggest drawing the picture, but since it says write down, that means you don't have to show any work. Okay, find an expression for f inverse. So f inverse, you guys all remember this, that f of x is y, and then you're going to switch x and y, and then you're going to solve for y. So this is something that you already did when you were doing it yourself. Divide by 2, and then y equals the cube root of x minus 5 over 2. Be careful whether the cube root goes all the way over or not. Now that would be the inverse. But I'm a little concerned, and my concern is we did have a domain restriction. So we had a domain restriction up here, so I might need to bring that up. So do cube roots naturally have a domain restriction? So cube root of something. There's no domain restriction, right? It could be any numbers. So I would be saying that this domain could be any numbers. We just saw one of those on 2016. We were just talking about one like this. So this is not the domain. Seems like. I wrote seems like. It seems like the domain is all real numbers, but it's not. Why did they just bring up the range of the original? Well, the range of the original is the domain of the new one, of the inverse. So this is actually the domain, not all real numbers, because I was restricted in the first place. Very tricky, but domains and ranges kind of switch just like regular x and y. If you want to remember inverses when you're doing calculus, when you have, let's see, we have x, y. I think that we only have 2 things in this table. Okay, so remember from AB calculus, we had this chart, x, y, m. So if you have f here and you have f inverse here, remember you had a point A, B, this switches to be A. Your slope in this spot, okay, so we'll call it M. This one flips to 1 over M. So the slope at A is M, but the slope of B on the inverse is 1 over M. So reminds you a little bit, just some extra, maybe it's on the IB test at some point. What if you had an x equals 5 vertical asymptote? What would that do on an inverse? Now remember, inverse just changes x and y. So that would just change to y equals 5, and then that would be a horizontal asymptote on the inverse. So that's interesting. So these two are just what ifs, a little reminder. This one's a reminder. This one's a beware. Okay, so beware, I think beware is one word. Anyway, so that's it for that one. Let's see, we're at 16 minutes. Oh, write down the domain and the range for F inverse. Oh, hey, I was all like excited. And they asked me that, so it wasn't a mystery. So this is actually B, and I like to label. So this is 2B. Okay, so this is 2B's answer. This one is 2A's answer. Write down the domain and the range of the inverse. So this one is the domain of the inverse. So what's the range of the inverse? Well, what would the range be of the inverse? Let's make just a little quick chart here. So I have domain, which is x's, and I have range, which is y's. So if I have my original, let's see. So if I have my original, I've never made this chart before. Okay, so if I have my original f of x, and then I have my inverse, the domain for the original was between -2 and 2. So that's going to switch over here to the range with a y value. Oh, I kind of like this chart. Okay. And then we just discussed that the range of the, we just figured this out, the range of this one is then the domain of this one, but with x's instead. So it's kind of cool. Very strange. It's 2017 and 2016. I just saw it. On Friday, I think. We're working on one on Friday. So anyway, so the answer to 2C is the domain of the inverse is -11 less than or equal to x less than or equal to 21, and the range is -2 less than or equal to y less than or equal to 2. I do like to write it as inequalities for this, but remember in IB, you could use their weird cool notation, which is a bracket. Oh, this one's not exciting because this one is bracket, bracket. So bracket, bracket would be the domain, and then the range would be bracket, bracket. Do you remember if it was a parenthesis, what they did in IB, if you've seen it in IB? So IB for parentheses, they do backwards brackets. It's very cool. Anyway, so for example, if you had 1, 3 bracket parenthesis for AP in IB, that 1 would be a backwards bracket. It's kind of cool. So backwards bracket, 3 forward bracket. It's very odd. Very cool though. They let you use either notation. It's just you have to be able to read both. Okay, so let's look at the next one. I love doing these problems. These are so much fun. Okay, let's see. Let's see 3. These are probably ones you might not need as much as the other ones. I kind of like this because I know some of you want help on these, but you're too intimidated and you don't want to ask because other people don't ask. First, fourth, and eighth term of an arithmetic sequence. Okay, first, fourth, and fifth, sixth, seventh, fifth, sixth, seventh, eighth. I like to see it. Of an arithmetic sequence with a common difference, D not 0. I'm going to make sure I write that. D not 0. Others I'm going to forget. Are the first 3 terms of a geometric sequence. Huh. With common ratio R. Interesting. So what I don't know right now, let me show you my 2 feelings. So this is geometric, this is arithmetic. So I have 2 choices. First term of both sequences is 9. Okay. Oh, well, I'll just use the formula for both. So this is 9. This is 9 plus D. 9 plus 2D. I know you could use the formula, but I think I could see it. 9 plus 3D. And this is 9 plus 7d, it looks like, right? 4d, 5d, 6d, 7d. Or you could use the formula. Okay, and then this one, if I'm doing r's, you multiply by r. So this is 9 times r, this is 9 times r squared. Interesting. So multiply by r, this is add d, add d, add d. So I'm not really using the formula, but could use the formula. Find the value of d. Well, 9 has to equal 9. Okay, that was boring. We also have 9 plus 3d as the fourth term, which is supposed to be the second term. So that's 9r. So that's one equation. And then I have 9 plus 7d has to equal 9r squared. Second equation. Maybe I shouldn't box them because they look like solutions, but I want to pay attention to them. Maybe I should just put stars. A system. I feel like I should use a system. So maybe minus, minus, minus. So elimination, 4d equals not like terms, 9r squared minus 9r. Okay. Not helpful. Okay. So much for my exciting problem. Okay, so I'm going to say no. Now, usually I would lightly erase with a pencil. So here's my light erasing with a pencil. So I can unerase later if I like it. But I think I'm going to change my mind. What I think I'm going to do is, I guess I'm going to make the D's match. Or let me just use substitution. So 3d equals 9r minus 9. D equals 3r minus 3. Substitute this into this d. Okay, this seems like it's going to work. So that's what? 9 plus 7, 3r minus 3 equals 9r squared. Now remember, you got to write in a way that somebody can figure out what the heck you're doing. Us, Miss Herzog and I, or the IB people. R squared, r. I'm on the calculator section. Calculator. Do you need to solve this by hand? You do not need to solve this by hand. Am I going to solve it by hand? I'm such a bad example. I'm going to solve it by hand. I'm going to solve it by hand because this is what? Minus 12. Wow, it's raining outside. Okay, so 9r squared minus 21r plus 12 equals 0 because I'm too lazy to go get my calculator on the other screen. How about divided by 3? Divided by 3. Oh, it factors. Oh, you probably just from here, seriously, you guys, from here, use a calculator. Use a calculator. Okay, so, but let's pretend we're on the non-calculator section. Like I said, I'm being a bad example. Okay, how I got that, if you forgot, is you multiply to be the first number. The middle is your check. And then the last, you're trying to multiply to be that. So I did 3r times r. 4 times 1, maybe 2 times 2, and then the inner and the outer, negative 4r, negative 3r, have to be negative 7r. So that's how I got the numbers. And then you use the zero product property. Now I'm only writing zero product property, is because sometimes you guys don't use the zero product property. When it's 0, you do the one product property. There's no such thing as the one product property. So zero product property has to be a 0. In my Algebra 1 class, we call this ZPP. ZPP for the 0. It has to be 0. Okay, so 3r minus 4 equals 0. R minus 1 equals 0. It only works if it's a 0. Mr. Lindsay's very cool. He calls it Jeremy, and he makes a little happy face. And if you know Mr. Lindsay, it's kind of funny because he seems all strict and everything. He's not. He's a great guy, but it's funny when he draws the little Jeremy. It's very cool. That's R. But remember they said D is not equal to 0. So, I mean, I don't know if these R's are valid. And did I do an infinite? I don't think I did an infinite. So I think we're okay with that. But let's see. If I do the geo, okay, so I have two possible geos. So this geo is 9. And then times 4/3 would be, you can use a calculator, 12. Times 4/3 again. Again, you can use a calculator, 16. Okay, so then that would be 9 is the first term. The fourth term is 12. Okay, definitely D is not 0. And then the eighth term is way over there. Oh, that looks like a +1, +1, right? 10, 11, 12. Okay. So, and then r is 1, though. That kind of makes me concerned. R equals 1. So 9 times 1, 9. Ooh, times 1, 9. Interesting. I don't know why it made me feel disturbed. So this is the arithmetics over here. So the arithmetics. Now remember, Miss Herzog's solutions are way neater than mine. So mine are interactive, but hers are way more awesome, okay? So I'm going to also upload PDFs for you so that you could see the actual solutions in her writing. And maybe we solved it a different way. So it'll be kind of neat for you guys to see different ways of solving it. So if that's 9, and that's what, 4th, 5th, 6th, 7th, 8th, 9th. What's the only way I'm going to get to 9? It's going to be they're all 9s. So what's D? 0. So r equals 1 is actually not possible. So this is my only r value. I could have also substituted back into one of the equations, I guess. That probably would have been smart, right? I could have plugged this r back in up here, and I could have plugged this r back in here. And when I plugged that r back in there, I would have gotten d equals 0. We would have tossed it out. So r equals 4/3 is the actual answer. Very interesting. Very cool. Okay, we're at 26 minutes. I'm only on number 3. So very interesting, but hey, we learned a lot. Passed just those 3 questions. Oh, 4 looks cool. 4 looks like an SVA from AB. Displacement S. Do they have the right letter? T. They have the right letter on the time. T1 less than T2. We'll see. Okay, that's going to be the next video. Let's just keep going. I don't know if I can make this video. I don't know how long my videos are allowed to be made. So let's see. Let's see how fast I can do it. Particle displacement S equals T plus cosine 2T. Oh, shoot. I think I'm going to need a calculator on this one. T is greater than or equal to 0. Look, it has a polynomial and a cosine. Oh, yeah, definitely I need it. First 2 times the particle is at rest. Okay, it stops when the velocity is 0. I think I could handle taking the derivative of this. So this is what? Minus sine 2t times 2. And then I need to set it equal to 0 to be at rest. And they want to know the first 2 times the particles. So they want us to solve this, which means I am going to have to graph it. This is 0. I'm going to have to find out when it hits the x-axis, right? So 0 would be this. And then there's the curve. And it's saying T1 is less than T2. So I'm going to have to find T1 and T2 based on the picture of when they cross. Find the displacement of the particle when T equals T1. So part B will be S of T1. Once I find it, I'll know. Okay, well, let me show you the graphing calculator. I do have a graphing calculator on here on my tablet. So let's see. Displacement, did I do anything? It gave me S. S is displacement. I don't need to take the antiderivative. I don't need a plus C. Nothing else is there. Okay, so I have it all set up. So I'll go to the calculator and see what it looks like. And hopefully the video doesn't cancel me out. Okay, so let's see. 1 minus 2 sine 2t. 1 minus 2 sine 2t. Okay, so let me go over to my calculator. Okay, I have to get back over here. Let's see. WAMU. Wabbit emu. Okay. Makes it a little smaller because it flips it over. Okay, so let's see. Oh, we have a bunch of junk in here from stats. Clear. It's kind of cool how the apps keeps all my stuff. Okay, undo the plot. Okay, I am going to graph 1 minus 2 sine 2t. Ooh, radians. I need to make sure I'm in radians. Okay, so radians. I'm going to go to mode. I'm not in radians. I am in degrees. Okay, then I'm going to hit zoom. I like zoom 4, zoom 6. Let's just hit zoom 6. Sometimes zoom trig. Okay, that seems good. I see both of them. If I wanted to change the window, if you hit on, it stops. Okay, but anyway. Okay, it's so weird that I'm using my tablet and I can't zoom in, but I can't. Okay, so I have that picture. I need to indicate that on the picture. I'm going to go to calc. Should I go to 0? You know what I kind of like to do? I kind of like to use intersect, so I make 0 as my y2. It's like a little cheating way so that I don't have to use 0. I don't like 0 because you have to go left and right, and intersect's fun. Okay, I like to hit intersect. See, there's my y equals 0 line. Oh, that's so cool in colors. So then I just go enter, 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 and it gives me one. Okay, now I memorize that x-intercept, and I write it on the other paper. So right now, I don't have a split screen, but I'll have a split screen in a couple days. So 0.26179. Okay, so I hit second quit, And then I hit X and I hit enter, and that is the number. I try to memorize it. So I'm going to store that as A. Oops. I'm going to store that as A. And then I'm going to go back and calc, intersect. Now if I hit enter, enter, enter again, it's going to give me the same answer. So I got to move my guess. I'm going to move my guess over here. Okay, so I did hit enter, enter, and then on my third one I went over to the other answer. Okay, so 1.308. Okay, so I'm going to hit X again, enter, and then I'm going to store that one as B. Okay, so those are my numbers. I should probably just write those on another piece of paper. Okay. How am I going to memorize those? Okay, and then I also need, oh, I forgot. It says S of T1. So S of T1, you can do, I don't know if you know this. This is cool. You can go to variables. Don't hit second. You can go to variables. You can go to Y variables, parentheses, and then you could put it in B. It's like F of X. So it's kind of cool. Oh, it's 0? That's interesting. So the displacement is 0? No, the displacement isn't 0. It disturbs me. Why not? Y equals. That's my derivative. That's my velocity. Okay, so let's go back. Okay, so let's go back to my quit screen. That's not helpful. So what I really want is I want S. So that means I need to substitute it into S. So S is not the same thing. So that would be, I could type it in for Y1, but I can just type it in. So that's B plus cosine 2B. B, but not B. Why am I doing B? It says T1. Okay, so T1 I think was A. Okay, so A. There we go. So that's the other answer. So I've got my 0.122. I've got that answer. Let's see, I got all my answers right there. So why don't I take a picture with my phone so that I'll be able to go back and forth. Okay, so I have all my answers there. There's A, there's B, there's position at that value, and we're good. So let me hit save, and I'll go back to my other screen. I'm going to see if I can memorize this. Maybe I should just use a graphic calculator on the side. Okay, oh my gosh, my split screen is going to be so cool. Oh, look at that. Look at that. I see them. We'll write them on your paper. You don't really need them on my paper. Okay, so 0.262. So this one, oh, I graphed it. I forgot what it looked like, though, so I should go back and see what it looks like. Okay, shoot. Okay, so A is the first time they hit. B is the second time they hit. And this would be T1 plus cosine 2T1, right? Well, the parentheses is really right here. And then I could approximate that value. So let's see. Let's see if I can go back and take a look at that. Okay, so that's 1.13. Right. Let's see. Sorry, my video is going all crazy here. So this is 1.13. Remember, you want to be 3 sig figs for IB. Okay, AP is 3 decimal places, but this is 3 sig figs. Okay, let me go back to the other one. 1.31. 1.31. Okay, so B is 1.31. Dot, dot, dot. Let's see. No, I think it's like 0.8 dot, dot, dot. So let's round. B is approximately this. So that's T2, 1.31, approximately, to 3 sig figs. And then A was what? 0.26? Okay, forget. 0.261. So 2.262. Okay, and that's also rounded. So that would be this one, 0.262. Rounded. But this T1 that I was using is really the exact value, so I probably would write that T1 equals A, and I would put 0.26. I think it was 1, right? So I would put that 1799. I usually stop right before a low number, so it's a 3, so then I don't have to decide round or, let's see, I don't have to decide to round. See, I should have made this another video. Okay, so round, I could just put the dot, dot, dot. And then that's what I actually used in here. I didn't round ahead. So that's the answer for those. Very cool. Okay, that's 35 minutes. That was way too long. Okay, so that's 1 through 4. And then I'll keep going on the other ones. Find the displacement of the particle in T equals. Okay, very cool. I would show the picture, so since we're already waiting here, so let's see. Let me draw the picture again on my graphing calculator. So the picture was over, under. Okay. Over, under. Let's see. I would draw the picture out because that's part of my work. So I would go like over, under, and then that would be enough because those would be my two values. And then this is a picture of velocity, not S, right? And that's why I almost screwed up and did not find S. Okay, very good AB question. It's good that we're cross-studying. An AB, ABC, it would be on that test as well. And then this is just, I call it SVA problems. You take the derivatives, remember S, V, and then A. The derivatives are down. And if you want to go up, that's the antiderivatives, and you need a plus C. So just a little review of SVA. We also do SVA in BC with vectors. So, but usually not on the IB test. Vectors are their own separate non-calculus thing, usually on the IB test. Okay, 36 minutes. Let's stop.